to find v of 10. I'm going to do it two ways. There are two options. What did you do? Okay, so you found v of t using the antiderivative, which is? And then what? Find c by plugging in 0 for your v of t and 1 for your t. It does turn out that c is 0. And then to find v of 10, you plug in 10 for t. 10 cubed is 1,000. 10 squared is 100. That's a plus, not a minus, isn't it? Yes. Let's fix that. Plus 200 is 1,200. Minus 30 is 1,170. Is that right? So that's option 1. I'm going to go up here and do option 2. With a problem that is non-calculator, option 1 works great. If you are working a problem that you must use a calculator, option 2 is better, and I will show you option 2. Yeah, so this one is probably a non-calculator question. This is probably how you want to do it.
Can you do option 2 on example 4 then?
I will, yes. I'm going to do it on example 3 first, but then we'll do it again on example 4. Yes. Look in the AP calculus box right there. See if it's at the top. If not, I'll find you another copy. I think it says that. Okay, option 2. Before we do, v of 10, would you agree is v of 1 plus the integral? Where in the world am I getting this stuff? I was squiggling. That's funny. So we have this equation. Again, I want to take the fear out of that equation. It's not a new equation. It is a rearrangement of the fundamental theorem of calculus. Wouldn't you agree from your mastery test that you have this memorized? Oops. Third change that. The antiderivative at 10 minus the antiderivative at 1, correct? Can you add the v of 1 over to find v of 10? Now, on this problem, would you want to do it this way? Probably not. But this now is something I could type in the calculator. Can your calculator do an antiderivative? This thing down here, can it tell you this equation? No. Can it do this? So, example number 4. Do you want to do that antiderivative? I think so. Because it's not a good use substitution problem because the derivative of the inside is 10x. And there's not a 10x on the outside. You see how that's a problem? This is not one that you will want to do an antiderivative of. I'm not saying it's impossible. You could probably pull a double use substitution to make it work. But who wants to do that, right? So, would you all agree that that other equation up there is worth learning? so that I don't have to do that antiderivative, because this is probably a calculator problem. So s of 5 is s of 2 plus the integral. Make sure this piece is up here. Even if it's backwards, that's okay, because it can work both ways. Just make sure whichever one is up out there is the one up here. From 2 to 5, v of t dt. Your calculator can do this integral for you. Y'all go do that for me. I'm sure there are a lot of things like that that look very interesting on video, like when I'm coughing and it looks like it's making me squiggle.
Let's put v of t in the
And what is s of 2? 7.
So how do you do math?
But if you forget that on the AP exam, do a 1/3 power. Isn't it the same thing? Sounds so excited about that.
Okay.
4, 5.
4, 4, 7.
4, 4, 7.
Okay, same thing on this one. Do you want to
I want to do it.
anti-differentiate that? No. So I'm trying to find the antiderivative at -2. That will equal the antiderivative at 1 plus the integral from 1 to -2. Remember, this one has to be on top. Some of you, that hurt your brain a little just now. Why? Those are backwards. Does it work out okay? If I subtract the 1 over the f of 1, is this integral not equal to antiderivative at -2 minus the antiderivative at 1? It's okay that it's backwards. Your calculator will take care of it. Just make sure this one's the one on top. What you're essentially doing is unaccumulating area. You're going backwards. So we have our starting point happened to be farther than our ending point, so we were going backwards. That's okay. While they are typing that in, Scott, it's pretty much what we learned yesterday. We are revisiting velocity, position, and acceleration. We learned that we can find the total distance by integrating the absolute value of the velocity function. We learned that the integral is net distance. That's actually what it's giving us, net distance traveled from point A to point B. And then you've seen some examples about this whole plus C thing, what that entails. There is a video, what do you think, is 15 minutes long from yesterday, maybe? Not real long. You tested? What is this, by the way?
4.88.
Any questions about those? This is what the AP packet looks like. We're going to work number 1 together. Did you find that, Scott? Okay. So a particle moves along the x-axis so that its velocity at time t from t0 to 5 is given by this function. At time 2, the position of the particle is 0. Find the minimum acceleration of the particle, find the total distance traveled, find the average velocity. You can probably tell by the setup of this problem that it is a non-calculator problem. We will approach these problems very differently when they're calculator versus when they're non-calculator. So this is a non-calculator problem. Find the minimum acceleration. Any ideas?
Derivative of v.
Okay, first I need to find the derivative of v of t, and to do that, if I were you, I would do algebra first. You don't have to do algebra first, but as you know, it makes your life easier. It keeps you from having to do product rules. Doesn't take you too long to FOIL that out. T squared minus, what is that? Minus 4t. Why wouldn't I do what?
No, what I'm saying is why don't you just do the v of t and set it equal to 0, get your zeros,
What would that give me?
give you the minimum velocity.
That would give me the minimum position, wouldn't it? Because you would do the derivative of position, so that equals 0. That gives you the minimum position, right? So, you gotta know what you're looking for, right? Which piece? So the acceleration is 6t minus 12. Everyone agree? I could. Before I do that, let's get a game plan. This is v prime, right? Is setting v prime equal to 0 going to give me minimum acceleration? What's it going to give me the minimum of? Velocity, right?
So I have to take the derivative.
Okay. Always important to know what curve you're on.
What's that called? So like, like
First, oh, that's just something you know from, it's really a physics thing, mainly from units in calculus. But for how to know to set each one equal to 0, you're doing a first derivative test, because you're doing the derivative of that function equal to 0. Does 6 ever equal 0? I am looking for the minimum from 0 to 5. Would you agree that is a candidate's test? Since there are no critical points, it's either at 0 or at 5. So I'm going to find the acceleration at time 0 and the acceleration at time 5. You could probably tell at this point, since the acceleration is positive, that it's going to happen at the first point, not the second one, but we'll find it just for fun. 30 minus 12.
I'm confused as to why we even needed the 6. Like, what was the point?
To see if there were any critical points on a prime.
So if you still had a variable in with that, then we would have...
And then it would go in with my candidates. Because you always put endpoints and critical points with your candidates. Good. So it says, let's go back and read the question. Find the minimum acceleration. The minimum acceleration is negative 12. Did this give us units? No. If it did, we would say feet per second squared, or whatever the...
You forgot, like, the units on the AP test. Or is that just, like, 1 point off?
Depends on the rubric. Sometimes you lose the whole point for the problem if it's a 1-point problem. Sometimes they'll throw in a units point on a problem. You saw that with related rates. You remember they'd say, like, they'd have a point at the bottom, correct units in parts A, B, and C. And they'd give you a point for that. So just depends on how they allot the points for that problem. On this one you wouldn't need to, but would it be okay if you did? So it kind of covers all of your bases, but since it just says find the minimum acceleration, it doesn't say justify, but if it did, all I'd need to tack on is say by a candidate's test. Because I've got all the work there, I would just need that one extra little sentence that says by a candidate's test. Total distance traveled by the particle. Again, I'm going to ask you, what am I given? I'm given the velocity. How do I find distance? Okay, I want the integral of the absolute value of the velocity curve. What was it? T minus 3 and minus 1?
We changed it.
Yeah. From 0 to 5. If I had a calculator, that's an easy question. I type it in and I push enter. I probably don't have a calculator on here. I don't know how to find the integral on an absolute value. I'm going to draw a picture. No. I never
They
have.
don't grade pictures.
They don't. Doesn't mean I don't need one. Would you agree the velocity happens to be a parabola opening up with zeros at 1 and 3? You can see there's a reason that I left it in factored form for this particular step. Here's what I need to know. I can do the integral of that velocity function by hand. That's not a problem. But how in the world do I take into account the absolute value? Everything's positive. Now, can I just take the integral and make the answer positive? No, why not?
Make the bottom loop go.
Okay, what I need to do is I need this to be positive, right? So what I'm going to have to do to make that happen is I'm going to have to integrate from 0 to 1, right? Plus 1 to 3. Except in my head, when I do that, I'm going to have to make that piece positive.
Since we know it's negative, we go ahead and just like do negative.
You could, yeah. However you want to write that on paper. Somehow you're going to do the integral by hand, but then you're going to change the answer to positive. This looks like a lot of work. The good news about it is when I do the antiderivative, won't that be the same for all three pieces? And so that part will be nice. Did we find total distance before we ever did integrals?
Yes.
We did, didn't we? In derivatives? Remember the silly little mouse diagram? Like we were going to the right, and then we were going to the left, and then we added up the total distance. I remember that? Didn't we find the position at all the turnaround points? And the endpoints? What is this integral going to give me? It's going to give me position at turnaround points and endpoints. Everyone agree with that? So same calculation, it's just a different way of looking at it. V of t, the integral of v of t, I am going to go back to the distributed form of v of t just because it's easy to integrate. What is the antiderivative of that? T cubed minus 6t squared plus 9t. So t cubed minus 6t squared. Was it minus 9t or plus? From 0 to 1. And like Grant said, you can either do absolute value, or since you know the answer is negative on the next piece, you could just change the sign. It's up to you. Same thing, t cubed minus 6t squared plus 90. Evaluated from 1 to 3. Absolute value on that. I wish I had that on your paper. Be nice.
Will we get more room on the actual test?
On the AP exam. Have I not shown y'all a booklet of what that looks like? I'll pass that around. I get these back when you're done. I'll know if you blew it off. This is someone's real test from last year. Doesn't have a score on it. It does come separate, but I get your writing back.
Do they mark in it at all?
They scan it into a computer. That's why, when they say you have to stay in the box, they're not kidding, because the outside the box doesn't get scanned in. You have to stay in the box, but the box is plenty big. You'll see that when it comes around. Okay, plug in 1. 1 minus 6 plus 9, 2. Minus 0. It's quite a bit of work. I've already plugged in 1, right? So I know it's 2. Save myself some time there. 1 minus 6 is negative 5. Oh, 4. I took Dominine's word for it.
Sorry.
She said 2. I assumed she was right. Okay, plug in the 3. 3 cubed is 27. And write this down. You don't have to do it all in your head. 3 squared is 9. 9 times 6 is 54. 27 minus 54 is negative 27. Plus 27 is 0. Plus 5 cubed is 125. 25 times 6, 150, is that what you said? So 125 minus 150 is negative 25. Plus 9, what did you say, 19? Okay, cool.
No, it's 19 plus 19.
Oh, I missed a T. Oh, good call. Thanks. So that would be 45. What was this again?
25.
25 minus 150.
So negative 25 plus 45. 20 minus 4. Again, you don't have to do all that in your head. Do some side work.
Where do you get marks?
Minus 0.
Yeah. That.
So what, 28?
Yeah, 28. Yeah, I don't know if pregnancy is a good excuse for that or not, but we'll take it. What I would really have done if I were really doing this is I would have written more out. Like, don't do all that in your head. On the AP exam, do some side notes. Where's that AP?
Could you have left it like that and gotten like more?
Yes, you could have left it like this and gotten all the points.
Could you have left it like the...
No. You have to show the plugging in. Now, you could have left it as 1 cubed minus 6 times 1 squared. If you wanted to write all that out, you could leave it like that.
So you could just plug in it?
Yes. It has to be numerical.
That's so easy though, because then you would never go wrong.
Yeah, you can do that as long as it's numerical. You can't leave it like this, but you can leave it as any numerical answer.
But if it's a calculator one, you can leave it like that and you can read it, right?
Yeah. Well, if it's a calculator, when you write this down and go boop, boop, done. You just don't do any work if it's calculator.
This person make a 5.
Yes. you remember 22 of them made 5. So if I randomly draw one out of the pile, the chances are they made a 5.
Show us one of the ones.
At the end of class, I'll grab one.
Would we be surprised looking at a one like how
Some of it.
would we like
Yeah, like what are they doing?
yeah.
Probably. On part of it, and then other parts, some of it's hard, so.
Will there be some stuff that we just don't know? We just be like, what is this?
AP will always throw something that's kind of out there. Is there anything that you will never have seen? No. Remember, we do 16 AP problems every chapter, plus all the multiple choice you do, plus 4 practice exams at the end that are different than the problems you've seen all year, plus all of your exams. You've seen just about everything that's out there. So
But they'll like try to get you.
there'll be something off the wall, but not very many things. There's only so many things they can throw at you that you haven't seen. Average value. How do you do average velocity? I kind of gave you the answer. We'll pretend I didn't do that. How do you do average velocity? Why average value? It doesn't say average rate of change. And what function do I have? I have velocity. I want to stay on velocity. Right? What's the formula for average when you want to stay on the function you're on? Average value. What if I wanted average acceleration?
Find the derivative and do that.
You could do that. You could do the derivative and then do that and it would work. Or you could do f of b minus f of a over b minus a, the average slope, because that would pull you down to the next curve. But if you want the curve you're on. Now, the cool thing about this is, do I need absolute value? No, so that makes this a lot easier. 1 over 5 minus 0 integral of v of t dt. I don't remember what v of t was. From 0 to 5. I know the antiderivative of v of t, though. I just did it 3 times. Well, I wrote it down 3 times. So I have 1/5 times t cubed minus 6t squared plus 9t from 0 to 5. I've even already plugged 5 and 0 into that. What did we get? 20? Is that what you said? 28? No.
It's
20. Because just when we plug the 5 in, not the whole answer from the above. Because that was the sum, or the...
Oh.
Right, the absolute value. We don't need absolute value. 4 meters per second, or feet per second. If we had units to use, we would use units. We don't.
Wait, so why is it 20?
20 is the 5.
When you plug in 5. Like if you just, yeah, you add it, see the 4 and the negative 4 on the real integral would cancel. That was the absolute value to get total distance. We don't have to separate it out for part C, which is nice. It's a cute little cartoon if you want to read it really quick. Then we'll go to another one. Sometimes we do that in calculus, don't we? Overthink things a little bit. He's got to find the area of a rectangle and he integrates it. And then the teacher's returning his quiz from last week. We'll do that AP practice tomorrow. Let's do another. Well, or we could just say, wouldn't you do a product rule? Okay. All right, let's do number 3. Maybe this is a calculator one.
Is S the first one? Is that what it is? So it's S, D, and then what does S stand for?
Position.
Oh, no, so it's just not.
Yeah. I actually don't have very many one booklets. I think I only have one. And it may be a 2, not a 1. Because last year we were piloted. We had 2 versions. And they don't release the second version. And most of my ones took the second version. Which sounds fishy. At first I went, whoa, is that a harder test? I was mad about it. But then I looked back, I think it was just luck of the draw. The people who would have made ones got the... So I don't know if I even have a 1 booklet. But I have one that's not as high as that one you have. Anyway, so I'll pass it around.
So on this one, the second derivative,
Huh?
and it says that x equals and y equals. Would you have to put, would it have to factor, would you have to find the negative?
Not, you could leave it. You can always leave it numerical. Now, the only time you'd want to is if you're going to use that answer for another problem, but
There it is, it's like C or something.
yeah, you can leave it numerical. We'll work this one tomorrow. Continue working on those problems I assigned yesterday.